All right, today we're jumping into something that sounds, well, completely impossible. We're talking about a cryptographic mystery that seems like a total paradox.
I mean, just think about that for a second. How can you have a signature that's both officially valid and completely anonymous? It's like it goes against the very idea of what a signature is supposed to do, right?
And this, right here, is the central puzzle we're going to solve today. It's all about signing something you can't see. So how is this even possible? Well, we're going to break down this little piece of digital magic. Okay, so before we get to the really wild stuff, we got to cover the basics. You have to know the rules before you can break them. So let's start with the foundation. What even is a digital signature?
Basically, it's just a mathematical trick to prove two super important things. One, that a message really came from you, and two, that no one's messed with it. It's pretty much the foundation of how we trust anything online.
So how does this actually work under the hood? Well, let's look at the classic example, the RSA signature. It'll show us exactly how the pieces fit together.
All right, picture this. You've got a bank and a customer. The bank needs to sign a contract. To do that, it uses its secret private key. This is something only the bank has. Then you, the customer, get the signed contract. So how do you check it? You use the bank's public key, which, as the name suggests, is out there for anyone to use.
And that's the core idea. It's this beautiful asymmetry. You sign with a secret key that only you have, but anyone can verify it with a public key that everyone has. That's what makes it all work. It's simple, it's secure, but it is definitely not anonymous.
Okay, now let's build on that. Let's add a little twist. What happens when one signature just isn't enough? What if you need, say, two different people to sign off on something for it to be valid?
Yeah, it's kind of like needing a cosigner on a loan in the real world. The digital world has the same problem sometimes. The question is, how do you get two different parties to come together and create one single valid signature?
The way they solve this is it's so clever. You take the secret key and you mathematically split it into two unique parts. Then each person uses their little piece of the key to make a partial signature. After that, you just combine those two partial signatures and boom, you get one final valid signature that works with the original public key. It's proof that both of them had to be involved.
Okay, so we've got the basics down. We've even looked at a cool little twist. Now it's time to get to the main event, the real heart of this whole mystery.
So here's the challenge. A document needs an official signature, but the person signing it can never see what's in the document. Think about it like this. You need a bank to sign a digital dollar to prove it's real money, but you absolutely cannot let the bank see the serial number on that dollar, because if they did, they could track every single thing you buy.
So how can you possibly sign something you can't see? It's a total paradox, right? The signature has to be official, but the signer has to be completely in the dark.
And here's the reveal. The answer is this brilliant, elegant idea called a blind signature.
The best way to think about it is with an analogy. Imagine you put your document inside a special digital envelope. And inside that envelope, there's also some, let's call it, digital carbon paper. You hand this sealed envelope to the bank. They can't see what's inside, so they just sign the outside of the envelope. But because of that carbon paper, their signature magically transfers right through onto the document inside. Then you get the envelope back, open it up, and take out your signed document. The bank has no idea what it just signed, but you have a perfectly valid signature.
And this is way more than just a cool party trick. This matters a lot. This is the kind of thinking that enables things like truly secure and anonymous e-voting. Or how about digital cash that's private and can't be traced? Or digital credentials you can prove without revealing who you are? Blind signatures are the key to all of it.
So what makes this whole thing possible? I mean, what's the actual math behind the magic? Well, it turns out the RSA algorithm has something called homomorphic properties. It's a bit of a mouthful, I know, but what it basically means is that the math just works that way. It lets you do a calculation on the envelope, and that same calculation gets applied to the secret message inside. It's the secret sauce that makes the carbon paper trick work.
Okay, so let's zoom out a bit. What's the big picture here? What should you take away from all this?
Well, the thing is, these aren't just academic puzzles. They are the actual tools we need to build a digital world where you can have both privacy and verification at the same time. You don't have to choose one over the other. This is how we build systems where you can prove something is legitimate without revealing everything about it. It's a total game changer.
And this leaves us with a really interesting final question. When our trust is built on code, on pure math like this, who do we really need to trust anymore? Are we shifting our trust from people and institutions to the code itself? It really makes you think.